Hello friends, today we are going to learn about Google Cloud NAT, which stands for Network Address Translation. If you already know what NAT is and what it stands for and why you should use it, then you can just skip ahead and see the hands-on demo where we will set up the Cloud NAT on GCP. But if you are new to the concept and if you need to just understand the basics, hang in here. And we will go through the theory and then we will do the demo. So let's get to it. So what is Cloud NAT? So for a minute, forget about Cloud NAT, because NAT, or Network Address Translation, is not proprietary to the cloud or GCP or AWS or Azure. It's a networking term, right? So if you understand the concept behind NAT, you will see that the same concept applies to any cloud or even the on-prem NAT, if you want to understand that, right? So basically NAT lets you access internet from certain resources. When I say certain, I mean infrastructure as service, infrastructure as a service resources, like your virtual machines, or in cloud you have cloud functions, or your cloud run services, all those things, right? At the end of the day, they all are, even though they are serverless, they are still infrastructure, right? So it allows you to access internet from the workloads that you deploy on your infrastructure components, right? So if you deploy an app on a virtual machine, or on your a GKE cluster, or you're running an app on Cloud Run, or if you wrote a function, and if you deployed something as an app engine, on App Engine. So in order to access internet from these services, you may need a NAT. Why do you need NAT, right? So think of it as when you create a virtual machine, right? A simple term. When you create a virtual machine, you get two type of IP addresses, private IP and public IP, right? In order for your virtual machine to access internet, you need public IP. Without the public IP, you cannot reach internet. Okay, so when you deploy an when you deploy a virtual machine, or your Kubernetes cluster, and if all the nodes, if they do not have a public IP address, and if you try to reach internet from those resources, it will fail. You can't do that, right? Why will you create these resources without public IP? Well, it's to increase the security, right? So just like without public IP you cannot reach internet, same way without public IP nobody from the internet can reach to your resources, right? So if you create a virtual machine without a public IP, of course now it cannot reach internet, but at the same time it is secure, because nobody from the internet can reach to your IP, to your virtual machine, right? So it has its own benefits and it has its own drawbacks, right? So you will find that in the large organizations, most of their virtual machines that you deploy, they'll be deployed using only private IP. They may not have public IP address, right? Because they do not want internet traffic to reach to their virtual machines directly, right? So in that scenario, you try to access anything from the internet from those virtual machines, it is gonna fail, right? But let's say you want to run yum update, or Windows update, or you want to do something, you want to reach to the internet and download some packages, right? Without public IP address you can't, right? So NAT allows you to access internet. It's a one way. It allows you to access internet from within those resources without having public IP address, right? Still, you create NAT does not mean that the traffic from the internet can reach your servers, right? So you still are protected, in a way that there is no incoming. It's only one way, it is outgoing. So you go to the internet, you fetch the updates and you download the updates, and it's all done. But nobody can initiate the inbound connection from the internet to your virtual machine to SSH, or if you have a website or something running there, they can't directly reach your EC2 instances, right, or your virtual machines, right? So that is the reason you want to use Cloud NAT, and or the NAT. And it doesn't really have to be Cloud NAT. Cloud NAT is like a managed NAT, right? So you basically can just create a virtual machine and make it work as a NAT. But then because it is not managed, you have some drawbacks. And what are the drawbacks? You will see in the next slide. But think of it as Cloud NAT is a managed NAT service provided by Google Cloud. I hope this clears out the concept behind NAT. Okay, now let's see why you want to use Cloud NAT, right? So, like I said, you can technically create a virtual machine and configure that virtual machine to be used as a NAT, as opposed to using a Cloud NAT. But why you want to choose to create or use Cloud NAT as opposed to creating your own virtual machine, right? So of course, security, it applies two ways, right? So you can reduce the need of your individual virtual machines to have external IP address, like we discussed in the earlier slide, that your virtual machines does not need to have external IP address or public IP address if you are using NAT and if you want to access the internet. Okay, now using Cloud NAT, you can get high availability, right? So because you are using managed service, making sure that that service is up and running is Google's responsibility. It's not your responsibility, right? So you are avoiding single point of failure, right? So if you create a virtual machine and use that as a NAT, and if that virtual machine goes down, now all the virtual machines that are relying on the outbound connection and are relying on that NAT virtual machine to be up and running, now they will lose the connectivity, right? So everything is down, right? You do not want that. Okay, you want to have high availability. You want to remove the operational aspect of your resources as much as you can, right? Of course you end up paying little more, but it is definitely worth it. So that is one of the reason why you want to choose to create Cloud NAT instead of creating your own virtual machine and use that as a NAT instance. And of course scalability, right? So if you have hundreds of thousands of virtual machines, and if they're all trying to update themselves at the same time, and if you are using your own virtual machine, that virtual machine which is acting as a NAT may not be able to keep up with all the traffic, right? And it will either crash, or it will just delay the updates and all that kind of stuff, right? So if you are using Cloud NAT out of the box, Cloud NAT will scale for you. Okay, you do not have to specify the scaling parameters or anything. So if you are if you have thousands of virtual machines trying to download the updates from the internet, and if you are using Cloud NAT, Cloud NAT will automatically scale for you. You don't have to worry about that. So these are the benefits of using Cloud NAT over creating your own virtual machine and make it work as NAT instance. So this is why you want to use Cloud NAT. Okay, now that we know what the Cloud NAT is and why we should use it, and what are the benefits of using Cloud NAT as opposed to using your own VM as a NAT instance, we are gonna do a demo where we will create Cloud NAT. We will set it up in such a way so that our virtual machines should be able to access internet and download the updates without having public IP or external IP address. And then we will look at the scenario where we want to use we want to use a specific IP address for a NAT instance, and I will explain why you may want to do that at some point of time, but it's a scenario just to showcase some of the capabilities or things you can do with the NAT. So with that being said, let's get on the GCP console and let's get it done. Okay, so let's start by creating a new project. Select new project. We are gonna name this Cloud NAT Demo. Click on create. We will select that project. Now, first thing we want to do is we want to create a virtual machine without the public IP and observe the behavior. So we go to compute engine and we enable the API. Okay, so the API is enabled. Click on create instance and we are gonna name this instance 1. We are gonna leave everything default, change the machine type to E2 micro, and we scroll down all the way to advanced options, networking, and select the network interface and look at the external IPv4 address drop down, change it to none. This will stop the virtual machine to have public IP address, and we click on create. Okay, now just by observing it on here, you can see that it has internal IP, private IP, does not have external IP, which is public IP. So let's SSH into the system and do a simple update, right? Sudo apt-get update -y. See what happens. It is gonna try to connect to the repo and download the updates, but it cannot because it does not have internet access, right? So now how do we get this machine to reach internet and download the updates, and so we can keep this system secure, right, or up to date? So let's terminate that and let's go and do our setup for the NAT. Okay, so in order to set up the NAT, the first thing we want to do is we want to reserve IP addresses which we will assign to the NAT, and go from there. So first thing we want to do is we want to go to VPC network, go to IP addresses, click on reserve external static IP address. This IP address belongs to the virtual machine that we created, the internal, so just ignore this one, and we are gonna name this Cloud NAT IP generic. I'll tell you why I named it as generic. You will see it later, right? So let's click on reserve. Now our static IP address is created. So let's go to Cloud NAT and click on get started. We'll name this my awesome Cloud NAT Gateway. Network will be default, region US Central 1, router, create new router. We are gonna name this my awesome cloud router. leave the default network and everything as is, click on create, and there are two drop downs here, Cloud NAT mapping, source, we are gonna just leave that one as is. For the Cloud NAT IP address, click on it and say manual IP address 1, select the IP address that we created in the previous step, Cloud NAT IP generic, and Cloud NAT rules. What this tells is if there is traffic going to any destination, which is what 0000/0 means, then use this particular IP address, which is the same IP address that we just selected, right? And it's the lowest priority rule, right? Remember, we are gonna have a demo. One of the step in the demo will be to work with creating multiple Cloud NAT rules, and I will explain what these rules are and how you can use them. So for now, let's keep this simple. Click on create. Now my Cloud NAT gateway is up and running, right? So what I will do is I will go to my compute engine, and I will SSH into it, and I will just clear out the prompt, and I will say same thing, sudo apt-get update -y, and you can see it is working just fine. Now it can connect. We didn't change anything on the virtual machine, we just created a NAT, and now it can connect. Now what IP address will I get if I ask the system to tell me what is your public IP address, right? So for that we are going to execute we are going to ask if config.co, saying tell me what's my IP address, public IP address, and it says this is your public IP address, 34.132.195.155. If you come back to Cloud NAT, you will see that this is the same IP address that we assigned, 34.132.195.155, right? Which means that the public IP address for this virtual machine comes across to the internet as the IP address of our NAT gateway, right? And because every traffic from this virtual machine goes to the NAT, from NAT it goes to the internet, right? So there is a middle layer in between virtual machine and internet, which is our NAT gateway. That's why every traffic that goes out, it gets the public IP address of the NAT gateway, right? So that's pretty much it for this simple demo. Next we are going to work on the NAT rules and see how you can use them. So let's do that. Okay, so now we are going to use Cloud NAT rules. You can see that when you create Cloud NAT, you get a default rule which says match any IP address, destination IP address, and use this particular NAT IP address. What it means is when Cloud NAT sees the traffic going through this particular IP address seeder range, in this case it is anywhere, this match actually translates to the destination IP, right? So if the destination IP is anything, then use the Cloud NAT IP address that we just specified, right? That's the default rule, right? Now let's assume a scenario where you have deployed an app or two apps on your virtual machines, and you need to give the IP addresses of these virtual machines to a third party, and that third party is going to whitelist those IP addresses that you give them, saying that as long as the traffic is coming from these particular IP addresses, it will be allowed, otherwise it will be denied, right? Because these are two different third-party systems, two different vendors, we can't really use, we can technically give them this IP address and be done with that, and that will allow communication, to those, third-party systems. But what happens is, if you deploy more virtual machines in your GCP project, then everybody can continue to, communicate with this third-party system, which may or may not be desired, right? So that is one of the things that you want to, keep in mind, that, you want to, make sure that, when the traffic is going to, these third-party systems, they all get different IP addresses, so that, there is no single point of failure, right? Because if that particular IP address, for some reason you lose it, you don't end up losing, communication to every third-party system, which has whitelisted that particular IP address, right? So in order to, provide sort of high availability for the communication, we are going to set up Cloud NAT rules, and we are going to, reserve a couple of more IP addresses, and we will set up those rules in such a way that we will tell Cloud NAT that, hey, if the traffic is going to, this IP address, which is third party IP address 1, then use IP address 1 that we will reserve now. And if the traffic is going to the third party, application number 2, then use another IP address, right? And for everything else, use this generic IP address, right? There was the reason I named this particular, IP address as generic, right? So now that we understand the scenario, let's go ahead and see how we can actually get this done, right? So again, same thing, we will go to VPC network, IP addresses, and we are going to reserve a couple of IP addresses, right? So we are going to name this one Cloud NAT IP 1, right? Click on reserve, and we are going to create one more saying Cloud NAT IP 2, and we are going to say reserve. Okay, now our 2 IP addresses are reserved. They are static IP addresses. They are not used by anything right now, right? So now let's mimic the third-party systems, right? So we go to virtual machines, right? And we are gonna create, two virtual machines that we are gonna, use them as our third-party systems, right? So we are gonna name this third-party system 1. We are going to leave everything as is. Now, because this is a third-party system, it will have public IP address, right? Because this is not in our control, right? This is somebody else's problem, how to secure it if it is, exposed to the internet, right? We are just creating a mock, setup to mimic these third-party systems. They are not going to be in your GCP project. They'll be hosted somewhere else by somebody else, and it's like a vendor system, right? So we will leave everything as is, and we will say create. This third-party system will have public IP address, and now let's create one more instance. Third-party system 2. Looks more or less same, everything stays as is, and we say create. Now these are the 2 third-party systems that are gonna be up and coming. Okay, now just ignore the fact that they are here. In real life scenario, these 2 systems are not going to be here, they will be somewhere else. All you will get is IP address saying if you want to talk to our system, then use these 2 particular these IP addresses. Okay, so so what I have done is I have developed a very simple Python application which literally does nothing. all it does is it exposes, you know, Flask. It's a Flask application, and all it says is, you know, I'm going to return the source IP address. Source is in, you know, from where the request is coming from, right? Because that's what we want to verify, right? So every time I make the request, it will tell me the request is coming from these IP address, right? So that's what we want to know. Now I'm not gonna be deploying this ideally, but what I will do is I will just, you know, SSH into those systems and host the applications, and I will, you know, come back to this when I'm done with that. Okay, so I have set up the systems, and these are the two virtual machines, third-party virtual machines where systems are running. Now I need to do one more thing. I need to create firewall rule, because these Flask applications, they are actually running on port 5000. Create. Okay, so ignore this name, I missed the 0 there, but you get the idea, right? Now let's verify that these things are actually working, you know. So let's go back to, you know, our compute engine, and just copy this, and we say http://:5000, and it is working. It is saying the request is coming from this IP address, which is technically my IP address. And let's do the same thing on the other one. Okay, so both these systems, third-party systems, are up and running. Now what we want to do is we want to set up our NAT rules, Cloud NAT rules, do what we are supposed to do. So we go to Cloud NAT, click on the NAT Gateway, and we say edit. And what we are going to do is we are going to say add new rule, and we are going to say if the destination is this guy, right? This is the IP address or public IP of, you know, our third-party system 1. So we say that if the traffic is going to external IP of system third-party system 1, then use the IP address NAT IP1 and rule number. Now the thing about rule number is, you know, it must be positive, of course, right? But the rule numbers are evaluated from 1 to 65,000, right? Where 1 is the highest and 65,000 is the lowest. You do not want to just start creating rules like 1, 2, 3, 4, 5, you know, those sort of priorities. You want to leave yourself some room so that you can, you know, make changes, right? So ideally, you know, I will start with 1000 and, you know, go from there, right? And we click on save. So what we are saying is if the traffic is going to this IP address, which is third-party system 1's IP address, use this Cloud NAT IP1. Save it. And because there is a comma here, save it. And that is done. We will add another rule. we are gonna say if the destination IP is the IP for system 2, then use NAT IP2, and I'm gonna number this one as 2000. And we say save. Oh, rule number. So that's what is happening. This thing is wonky. Save it. Now we have two rules, 1000 and 2000, and that's what is happening. So if we now do a curl from one of the systems to these IP, we should get Cloud NAT IP1, or if we go to the other system, we should get Cloud NAT IP2, right? So let's verify that. Do is I will actually just SSH into this system, which is instance 1, and I will just say curl http:// external IP for our third-party system 1 :5000. Let's see what does this say. The request is coming from 35 to 32 91 245. Let's verify that's what we set up. There it is. So we are going to 34 70 76 98, and we want it to use .245 IP address, and you can see that, right? Now let's do the same thing on to now let's go here on the second system. And you can see that now it says the second system says the request is coming from NAT IP2. That is exactly what we wanted, right? But now if I just say curl ifconfig.co and say what happens, now it is saying that the external IP address of this system is .155. So .155 is the generic IP address that we said, and now this proves the point that you can set up Cloud NAT rules and ask it to use different IP address based on what is the destination IP address is. So that is all for this Cloud NAT demo or lesson, and I hope you guys enjoyed it. So I will see you in something else.